Good morning, everyone. This lesson is titled Introduction to Computer Networks. I'm going to start by definition of LAN, advantage of LAN, essential feature of LAN, and after that I will explain you the different topology of LAN and hardware or network devices. And after that I will give you an example of local area network and the two kind, which are client server LAN and peer-to-peer LAN. I will explain the notion of metropolitan area network and the wide area network and define for you the protocols and collision domain and broadcast domain. So a network is an interconnection of devices often called node, such as, for example, personal computers, servers, consumer, electronic, etc. LAN is the acronym of local area network, which connects computer within a limit geographic area, for example, home, office, or school. This kind of network allow us to share resource and data. IEEE 802.3, popularly called Ethernet, is by far the most common type of wired LAN. In LAN, each device share the same IP address. For example, if we use a network that have this or has this address IP or IP address, all IP devices, computer, printer, IP phone should have the IP from the same network range. Okay. So, what is the advantages of LAN? The first one is efficient resource sharing. So the sharing of resource and the exchange of information can be possible in this kind of network, or this network help us to do this. Enhance communication and collaboration. The method of communication such as email, instant messaging, etc. LAN allow us to enhance organization, so we become able to centralize data and make it more accessible. Also, network administrator can manage the network from a single location, allowing them to troubleshoot issues more quickly and effectively or efficiently. We have another advantage which is improving security. So LAN can enhance security by enabling organization to centrally manage and restricting access to specific resource, application, or services. In the right side of this slide, we have an example of local area network which contain switch, servers, computers, IP phone, wireless router, and two laptops. All these devices are connected with cable. So it is an example of wired LAN. And the two laptops are connected without cable to the router, which is embedded, or which contain network adapter or a wireless network adapter. Essential feature of LAN. The first feature of LAN is the size or the coverage area, which is generally a few kilometers. As we can see in this table, we have an area of 10 meters. For example, it can be a room. This kind of network is called local area network. And for example, for 100 meter we have a building, and it is also a LAN. For 1 kilometer, it can be a campus, and it is also a local area network. For more kilometers, we call it this network MAN or WAN, depending on the area, the covered area. Essential feature of LAN, we continue with speed. So it is one of the characteristic of LAN is their higher speed data transfer. So WAN are slowest. WAN is a wide area network, so it's cover more important area than local area network, and we conclude that local area network is higher in speed data transfer than wireless area network. You can achieve a transmission rate of 1 megabyte per second or 100 megabyte per second or higher using different dedicated transmission medium. We can use, for example, Ethernet cable, thin, thick, or twisted pair, and we can use also fiber optic or wireless transmission. Why not? We have the third feature, which is topology. So different topology can be used, and the two topology, bus and ring, are the most used in local area network. Quality. The communication quality is better in local area network, and the bit error rate is less than in one or wide area network. So we have more error in WAN than in LAN. Cost. LAN have a low cost, relatively simple installation, expansion, and maintenance. In this slide, I'm going to explain you topology of LAN. So we have two kinds of topology. The first one is the physical topology, which refer to the layout and or arrangement of network devices, cable, and hardware component. We have different topology in the picture. For example, in the upper right side of the picture, we have star network topology, which is characterized by a central hub or switch that connect all devices. Data is transmitted from the device to the hub, and then the hub broadcasts the data to all other devices on the network. The star topology is easy to install and manage, and a single device failure does not disturb the entire network. However, installing it can be expensive, and the hub can become a single point of failure. In the bottom right side of the picture, we have the ring topology, where data is transmitted in a single direction along the ring in the topology where devices are connected. Each device receives data from the device before and pass data to the device after. This topology is reliable and efficient and can be expensive to install, and a single device failure can disturb the entire network. In the center of the picture, we have the mesh network topology. So, in this topology, devices are interconnected in a decentralized manner. We can have all the devices which are connected, and we call this fully connected network topology, as shown in the upper left side. We have the fully connected network topology, where each device is connected to all the rest of the devices. And in mesh network topology, we have some connection between some computers or devices. So the start, in mesh topology, instead of relying a central hub or switch, each device connects directly to multiple other devices, forming a mesh link structure. In the left bottom part of this picture, we have the bus topology. So it connects all devices to a single cable known as the bus. Data is transmitted in both directions along the cable, and each device receives all the data transmitted on the bus. The bus topology is simple, easy to install, and susceptible to data collision, and difficult to troubleshoot. So if the bus breaks down, the entire network breaks down. Here we have some example of topology of LAN. We have in the right side the ring topology. It is very clear that the 4 PC are connected with cable following ring topology. And in the left side we have the bus topology. So we have one connection from the hub, and the bus are connected to all the PC. Here we have another example of topology. We use hub. So from the first hub we have 2 other hub or 3 other hub that are connected to the first hub, and the 3 hub are connected to some PC or some computers. This is star topology. We have the second kind of topology, which is logical topology. So this topology describes how data is transmitted between devices in a network, regardless the physical topology or without taking into account the physical topology. The first one is the broadcast topology, and the second one is the token passing topology. So in broadcast topology, this topology allows a host to send data to all other hosts available in this network. And in token passing topology, we share data with various hosts through access to an electronic token, which is represented in the right picture by the red circle. So this token go from one PC to another, and if we have the token and we have also data to transmit, we keep the token, we transmit our data. After the transmission or the lapse of time duration, we return the token to the following computer in the ring. Here we have an example of network which has logical bus topology and physical star topology. It can be very clear in the picture. We have a hub or switch which connect a different computer or equipment, and the transmission follow the logical bus topology, which means a broadcast topology. So here we are going to explain the different hardware or network devices used in network. We start by the repeater. So it is a 2-part device that operates at the physical layer and allow to amplify and regenerate signal following the rule 543, which is designed for the number of repeater and segment on shared access. A hub, which is represented in the little picture. We have a hub is a simple type of repeater that operate at layer 1. It is a multi-port repeater and it's enable the connection of multiple devices to the same network. Hub does not break up collision domain, so all the port on a network hub send the same traffic. It doesn't make decision about traffic and can cause congestion. It is gradually replaced by switch and has not been manufactured for a long time. We have three kinds: active hub, passive hub, and intelligent hub. So active hub do amplification of signal if it is necessary. Passive hub don't do amplification, and intelligent hub allow to help administrator in repairing troubleshooting. Bridge is a network device of layer 2 and which is a data link layer. It has only 2 ports and allow to filter traffic between 2 physical segments based on MAC address. Bridge allow us to break up collision domain into 2 parts and can reduce network congestion. So as I am saying, it separates the network into 2 collision domains. Switch. So the switch is a layer 2 device and the basic building block. It is considered as a basic building block of Ethernet networks. It allows us to forward unicast traffic to a single host or broadcast traffic to all the computers in the same network and multicast traffic to some networks to some computers in the network. The switch allows us to break up collision domain and greatly reduce network congestion compared to network hub. It learned the MAC address in the first step. It learned the MAC address of the connected devices, and when traffic needs to go to a specific device, the switch sees the MAC address in the packet and send it to only that device. In the picture below, we can see the switch. And in the right side, we have the table or the commutation table that summarize all the learned address MAC corresponding to the interface or the appropriate interface. So when the switch receives a packet, it search the corresponding MAC address in the table and send the data to the corresponding interface. Router. It is a layer 3 devices, which is a network layer. It is the network device that deal with IP address and allow routing packet between networks, different networks domain. It forward traffic using a routing table to the right destination, and it is characterized by a limited number of interface. Limited number, but different kind of interface. It has a great diversity of interface, allowing the professional equipment to connect to any technology. In the bottom, we can see an example of the router. Here we have an example of a local area network. In this picture, we have a hub, also known as multi-port repeater. This is the most basic device that allows central connecting. It connects each of the computers and servers by cable. When the host needs to send data, it first sends data to the hub, where it is amplified and broadcasted to the rest of the network. Broadcasting means that the data is sent out to every host on the network. Only the real receiver keeps the data, the rest of the host drop it. Despite the disadvantage, it was the standard for a long time. Actually, switching technology is the standard and is more efficient. Here we define the two kinds of local area network, which are client-server LANs and peer-to-peer LANs. So, client-server LANs consist of several devices or clients connected to a central server. The server manages the storage of information, application access, and network traffic. A client can be any connected devices that run or access application. The client connects to the server either with cable or without cable. So we have in this case a wireless connection. One can imagine a company information system as consisting of one or more databases and some number of employees who need to access them remotely. In this model, the data are stored on powerful computers called servers. Often, these are centrally housed or maintained by a system administrator. In contrast, the employees have simpler machine called client on their desk with which they access remote data. The client and server machine are connected by a network as illustrated in the right picture. We have two processes that are involved in the client-server model as follows. The first one is when the client process sends a message over the network to the server process, which is called request. And the second one is when the server process gets the request. It performs the requested work and sends back a reply. Here we have advantages and disadvantages of this kind of architecture. The first one is centralization. So information are placed in a single location. Updating data and resources become very easier. And the second advantage is security. So data is well protected because it is placed in a single location. The third advantage is scalability, which is the possibility of increasing the number of resources such as client and servers. Management, we need to have administrator, and the centralization help easier management. Accessibility, whatever the place of or the platform client or employee can access their information. As disadvantage, we have traffic congestion. So it's if too many clients make requests, we call this situation a congestion. We have the robustness. If the server breaks down, the whole network will be disturbed, or the whole network breakdown. Cost is very important comparing to the second architecture that we are going to see. So the cost of setting up and maintaining the server is usually high. And we have maintenance that cost or that have an important cost. A specialized network manager should maintain the server. The second kind of network or the second architecture is the peer-to-peer communication, also called person-to-person communication. So it is another type of model. And in this model, it is possible for one computer to play the role of client and server at the same time. The simplest peer-to-peer networks is two directly connected computers. Wired or wireless connection. It can be the two kinds of connection. Both computers are able to exchange data with each other over the network. Both of them act either as client or a server depending on the situation. Multiple PC can also be connected by a large peer-to-peer network, as shown in the right picture. Every person can communicate with one or more other people. In the table, we have advantages and disadvantages of this kind of architecture. So it is easy to set up, less complex and less cost because the server are not required and an administrator is not required. No centralized administration is the first disadvantage. We have a network which is not scalable, so we can't add computers wherever we want. It is not very secure, and each computer can be client and server at the same time, which can reduce the performance. MAN is the acronym of Metropolitan Area Network, which cover a metropolitan area, which can be city or suburb, and which allows at least two LAN networks to communicate with each other. This kind of network can be used in the case where, for example, several branches of a bank want to communicate with each other. WAN is the acronym of a wide area network. So, wide area network interconnects several geographically dispersed local networks, access remote file server, and share a resource, for example, printer, computer, and other equipment that can be connected to a LAN. In this way, possibly distant companies can communicate with each other, exchanging information, file, resource, etc. User of the network must be able to communicate and access remote resource in real time. The most common technology for wide area network are ESDN, DSL, frame relay, etc. This network speed is less than the LAN network speed. So, in this slide, we are going to define the notion of protocols. So, what are protocols? Protocols mean the set of rules. It is a formal description of message format and the rule two or more machine has followed to exchange message. The key elements of a protocol are syntax, semantics, and timing. Syntax refers to the structure or format of data. Semantic refers to the meaning of each section of bit. And timing refers to when data should be sent and how fast it can be. As example, we can use protocol to know how to computer connect, how to format the data to be transmitted over the network, how to manage timing in data communication, how to send data, how to control transmission error, etc. We have many examples. In this slide, I'm going to explain you the collision domain and broadcast domain. So, the collision domain describes a set of computer equipment, computers, printers, servers, etc., connected to a central, non-intelligent equipment, for example, hub. All data sent by one of the host equipment will arrive at the central network equipment and then be sent to all other equipment without exception. A network where many collisions occur has a negative impact on the good functioning of this network. Segmentation consists of dividing the collision domain into smaller collision domain by adding intelligent equipment. For example, we have switch or bridge. The use of a router allows breaking the broadcast domain. In this picture, for example, we have a network where we can find switch, router, computers, hub, etc. As we can see in this picture, we have different red circles that represent all the collision domain. So all the connected interface of switch represent one collision domain. The blue circle represents the broadcast domain. So each interface or connected interface of the router is represent a broadcast domain. Thank you for your attention, and if you have a question, please ask your question in the comment. Thank you.